Oh, hello, Bren. Yes. How do I get rid of that? I don't want that. Kaya, how are you doing today? Good. You know what? Are you always an up person? Positive person? Not really? Oh. You seem to be that way. My older brother's that way. And my younger brother's that way. The rest of us got the disease. Alrighty. Noah, can you hear me?
Yes.
Are you planning on turning your student information sheet into me?
I think I have that. Did I not turn it in the bin?
I did not find it in the bin.
Let me go look.
Okay. You could still turn it into me. It's not a big deal. I just wanted to know. Anybody want an expired coupon? Dom, are you planning on turning your information sheet into me? Just wondering. Cole, are you here? Haley, are you here? I wonder if I'm on the wrong class. Let me try this again. I bet you I clicked the wrong one. No, I picked the right one. All right, let me go to here. Oh, let's see this. How do I get this down? All right, a couple of things. Hi. I have something for you, but not at this time. Okay. I got to figure out how I can do it and feel safe at the same time. Will you close the door behind you? Okay. So what happens is people come late to class, and I don't get too bent out of shape about that. It kind of happened with somebody yesterday in here. Who was that? They tried to get in. And so what happens is somebody texts somebody, says, hey, I'm waiting to get into the class, and I'm in the waiting room. And when that happens, can you just, rather than text me, just say Mr. Kruger, Bob, or Emma is in the waiting room. Can you let them in? Because once I switch over to my camera, I'm clueless with everything else. Is that going to make sense? So that's one thing I want to talk about. I got to take roll here. Haley, I see you're here. Correct?
Yes, I'm here.
Okay. Heidi?
I'm here.
Hey, Morgan?
Here.
Ella?
Here.
Noah, I already talked to. Bryn, I saw. Gus.
I'm here.
You know, Gus, I like your nickname and I really like your middle name. That's my brother's name. You're like,
That's pretty cool.
yeah, it's going to be really hard not to give you an A. I have to figure out how I'm going to do that.
Wouldn't turn it down.
You wouldn't turn it down. Good for you. Zach, are you here?
Yes, I am.
Christian. Lee.
Hello.
Nick.
Here.
And was it Olivia here? Olivia. It's one of my favorite names. Olivia is just it's kind of musical. Though I don't know any songs, but I do know, okay. Noah McDonald. Okay, Noah, I gotta get used to you. Dom, I know. Ari, right here. Ari, I know. Jack, I know. Bryce. Bryce, okay. Jake Peters, right there. I think I knew that. Darcy, I know. And Cora, right there. And Kaya, I know. All right, super. So I'm going to hit save. Everybody's present. And I'm going to share my screen. And I looked at homework. I was hoping to get further than I did. So I'm going to share the screen. And I want to talk about what was due last night. And I was really happy that somebody said, Kruger, you said it's due at midnight. Because I forget those kind of things. And I kind of talked about this one in class. I want to talk about number 2. This one. This one right here. I had a lot of people that had this wrong. First of all, notice you're going to pi. That's an angle measurement, correct? I see people over here are nodding affirmatively, right? Because you're going to plug pi into sine. Now we should know the sine of pi. We should know what we're measuring in because we measure angles in 2 units of measure. One is degrees and the other one is radians, correct? This is like way too tight. Sorry about that. So this is in radians. So you need, in this class, you need to make sure that your calculator is in on radians. If you don't know how to do that, I can help you with that. You should also know that the sine of pi is 0. So 0, e raised to the 0 power, or anything raised to the 0 power, is what number? 1. So the first thing I try to do anytime I try to find a limit, I see if I can substitute. And since I'm thinking that the limit is 1, since I'm able to do this. And I know somewhere down here it says sketch the graph, so I think I got the graph on my machine here. And I'm going to turn these off. I didn't mean to do that. I want to hit this. And I want to select this. I want to draw that. And I want to change my window. And I want to be between 0 and 4 probably. Oh, that's not even correct. All right, let's exit C. Pardon? I gotta make sure I didn't accidentally change this to degrees. Yeah, it's radians. So if I take a look at that, there is my graph. So it's continuous. Would you agree with that? So I can, when it's continuous, I could do direct substitution. And I'm just going to verify this by tracing. And I'm going to put in pi. And I get a y value of 1. So the limit's got to be 1. Secondly, the numbers that you put in here, so I have 1, 2, 3, I'm going to put in pi. What would I put in here? I'm not going to put negative numbers in here. This is 3.1415. So I could put in 3.13, correct? I could put in 3.1. I'm going to put in 3.08. Those are numbers that are left of pi. So over here, I could put in 3.15, 3.142, 3.141. And I could put those values in because these are all, I want this to be not 19. So these are all numbers that are greater than pi, but are moving closer to pi. And these are all numbers less than pi, but are moving closer to pi. So you don't want to pick a -2, a -1, 0. You want to be really, really close. Does everybody understand that? It's kind of like looking, this is the math thing of looking into a microscope. Everybody understand that? Okay. So I want to talk about that. It's continuous would be your answer. And so here it's 1, and the limit is 1, and you can say as you approach from the left and the right, it's the same, and you can draw that graph. All right. What was the other thing I wanted to talk about? I want to talk about this. So for each of these, you need to give me a table. So if you didn't give me a table, I did not give you credit. Does everybody understand that? And so you would put this into your y equals. And so my table would look like this. And then somewhere in the middle, I'm going to have 2. Does everybody understand why I pick 2? And I plug 2 into here, and I don't have a problem. I don't have division by 0, do I? So I'm going to get 10 divided by 3, it looks like, 10/3. Right? Or 3.3 repeating. Am I right on that? Okay, thank you. And then what am I going to put in here? I'm going to have about 3 on this side. So this is x, this is f of x. This is in here, and so I'm going to have, let's see, 1.99, 1.99, 1.9. Those are really, really close to 2. Then over here, I'll probably have 2.1, 2.01, and 2.001, and then I'll put those in. Then it says, okay, what about if you approach from the left, right? 0's got a minus sign. Do I even need to make a table here? No. Why is that? Why can I get by and say not possible? What? Yeah, why is it undefined? I agree with you 100%. Right. Negative numbers are not part of the domain, correct? And so I would say x cannot be less than 0. Is there a reason you have your computer up, Jacob? Oh, okay. Are we done doing that? Yeah. Oh, okay. All right. And then here, you're going to do, now you can only, so this, now you're going to go from the right, correct? So I just need a table with values from the right. So in other words, it's going to look like this. Here's x, here's the square root of x or f of x. 0 is going to be here, 0 is going to be here, correct? Because I can plug in 0. And so what will I have for values? Well, I'll probably have 0.1, 0.01, 0.001. And I'll plug those in there and figure out what values I get, and they should be pretty tiny. What about this? Well, this wasn't possible, correct? You only have a limit from the right. So there's no overall limit, is there? It does not exist. But there is a limit from the right. There is a right-hand limit. And there's some functions that only have right-hand limits, square root being one. What I would have done here, I think this is, you're okay, right? Because I've already kind of talked about that, right? And so I'm going to have h here. And I'm going to have f of h here. All I'm doing is my variable is different. So I'm going to put 0 in here. And I'm going to have 0.1. Now, when you go to your calculator, you can write this as 6 plus, you can simplify it if you want. 6 plus 2h minus 6 over h. Ooh, I need a red pen. I get 2h over h. I get 2. I think I'll get 2 all the time if I plug my table in. Right? If I did a little algebra, I can do that. Now, you didn't have to do this, but it might have shown up, oh, every time I do this, I get 2. I wonder why that is. Well, if we do a little algebra, we can see that. And that's kind of where we're headed today. We're going to do a lot of algebra today. So we find out where you're strong at algebra and where you're weak at algebra, and we make you better at algebra. And what a lot of students say is when I take the ACT after taking calc, math part is really easy. Because you review all that stuff. Especially if you took stats last year, you need a little review because there isn't a lot of algebra in stats. So that's good. Any questions on this so far? Does that kind of make sense? Did I do an okay explanation? I also read your student info stuff. I really liked your comments. And the idea is a lot of you wanted really good explanations that are paced well. So Kaya, here's my issue with me. I'm a flawed human being, okay? I know that. I'm reminded of that every day. And I really like math. And when I really like math, sometimes I forget you guys are here and I start going really, really fast. Somebody's got to say, whoa, you're going like way too fast. Can you kind of explain the better job? That's your right to have a good explanation. Does everybody understand that? I need to be the best every day. And when I'm not, Cora, and you say, hey, you didn't do a very good job, that's okay. You're not going to hurt my feelings. I have no feelings anymore. You can't hurt, like if you have no nerve endings in your hand, you can take a hammer, go bam, 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 like that, and it doesn't hurt. your brain, your hands are bloody and probably in bad shape, but the pain receptors aren't there, right? Okay. That's the way I am with feelings. All right, so I want to talk about this one using graphs, okay? Because I saw some things. Everybody did this one pretty well. This one is a huge one. This is huge. I think I wish I had more problems like this, because this is the problem that you see on the AP exam a lot. And so what I do is, I'll show you my steps, okay? First of all, I got to draw a graph. A graph just isn't a couple of dots. Does everybody understand that? And Jack, does it bother you if I talk to you? Okay. So Jack sent me a picture and say, hey, can you give me some ideas of how to do this problem, right? I really like that. And I try to get back right away. Some people sent me stuff on the email, and my phone was dead, so I had to charge it. And then my wife and I spent some time together. We were talking, watching a show called Away. So I didn't do a very good job once it became 8 o'clock of answering any questions. So, but you sent a picture, and then I kind of gave you enough hints, and then you showed me what you had. It was perfect, wasn't it? So the first thing I would do is plot 3, 2. And it doesn't have to be perfect. Okay, so boom, I have that done. Now, the limit as I approach 3 from the left equals 4. Well, there's 2, 3, 4. And I'm headed towards 3 from the right. Well, it's got to be a function, so this has to be an open circle. And this has to be an open circle, correct? Now, that is not a graph. But do you see why those have to be open? Now, the other thing it tells you that the y values, right? F of x computes y. And you'll say, why does he say that all the time? Because you will forget what f of x does. I guarantee you. But it always computes your y values, right? In your ordered pair. They got to be positive. They got to be the x-axis. So this is me. Some people just use lines. I like curves. Oh, there, I'm done. You can put arrows at the end if you want. It doesn't have to look like that. Does that? And I could have went up and came down. Okay. I needed you to be able to do that. All right. Abisters, okay. All right. This one went pretty good. And then there was a problem from HE double toothpicks. This one right here. And to tell you the truth, the way I correct these is I have a 4-step process. First, first thing I do is, was it in on time? If it's in on time, you're going to get full credit for how I scored. Does everybody understand that? So that's the first thing I look at. Was everything turned in on time? Second thing is every problem done? Because problems that aren't done, I take off 1/10 of a point for every problem that's not done, and it starts at 1. Okay? Last one, I pick special problems. Are they done? And this was special problem number 1. These 3 were special problem number 2, 3, and 4. So it says, okay, G of B. What is the Y value at B? Here's B, here's the dot, here's the Y value, it's M. Then here's G of 0, where here's 0. G of 0, that's K. Dom, is that better? Okay, sorry about that. And then what's the limit of g as you approach 0? Well, the thing's continuous, isn't it? So as I approach 0 from the left and the right, if I'm going to go to k. So those are the ones that I checked. Does everybody understand that? Because those are the important ones that you're going to see somewhere down the road. Abisters, any questions? You know what I don't like? I don't think I can do that. I have no idea. All right. So we're going to shift gears. And we're going to talk about these notes. Okay? And I thought I had them done and I was going to post them, and I found out I didn't have one side done, and they will be posted, my notes. You understand what I mean? My notes will be posted tomorrow. You know, these blanks are always on there, but then you see my beautiful handwriting or printing. You're going to get that also, okay? You're welcome. Guys, thank you. Grace, I like your glasses. I don't like these glasses. Everybody else likes them. I don't like them. So here's the big thing, and I ran into this last year. Oh, so now do we understand? I like this picture. Who is this person? I wish when I hovered over their look, I knew who they were. That's kind of cool. I ran into this last year. So first of all, does everybody understand? Keep your calculator in radians. Now here's the issue you're going to run into. In the description of taking calculus, I really encourage you to take physics at the same time. It does make it easier. I don't know if you guys ever look at that book. Probably not even last year you even looked at that book because it was so crazy last year. But if you happen to take physics, he does everything in degrees, which is okie dokie. You know, because he has people that aren't in calculus. But you'll find out if you did take physics, having calculus makes physics a lot easier. But and he's okay with it. But if you are taking physics, you got to switch back and forth because we're always in radians. There are a few exceptions, but very, very few of them. Okay? Has everybody got that? The second thing is this word analytically. And I ran into this a lot last year, and it's because I don't think I emphasized it enough. When you get a quiz or a test, and I ask you find the limit using the table, you'll use the table, okay? If I ask you to find the limit using the graph, you'll use the graph. If I ask you to find the limit analytically, you have to use algebra. So when I was a student, what I did is I would put the equation, well, no, I didn't. I'm lying, because I didn't have a calculator when I was in school. I didn't have a graphics calculator. I didn't have a calculator when I was in high school. I had a thing called the slide rule. But when I got to college, I had a calculator, okay? So what I would do is when we were supposed to do it algebraically, we'd even have tables. I would put numbers in and use my calculator to figure out what the numbers were, so I had an idea what the answer was. Does everybody understand that? But I couldn't use that as showing my work. I had to show the algebra. And if I didn't get the answer that was in my table, or for you guys on your graph using your calculator, that means you made a mistake somewhere along the line. Has everybody got that? Okay. And I know you can get the correct answer using your graph and your table. but you have to show your algebra if I ask you to do it analytically. Abisters, is that making sense? All right. So there's a couple of things. Let me get my notes out so I can take a look at what I wrote here. I'll do it this way. All right, so I never give myself enough room. There are certain properties of limits. So what it's saying here is you have a limit of a function as x approaches c, and that limit is going to be called L. Okay, it's guaranteed to have the limit. This one is a different function headed towards the same number, okay, on the x-axis, and its limit is k. All right, so if I were to draw a picture of this, here's c. Oh, let's draw this. This is f, f. And so this right here, there's L. Okay. And then here's another. Here's G. Are you guys okay? I don't write G of X. It's me being lazy. Okay. And right here, this is K. So it's a different Y value. Okay. So this point is C comma L. This point is C comma K. So what they're saying, and I'm going to draw it by scalar multiplication, what they're saying is if I have the limit as x approaches c of some number that I'll call a times f of x, that is the same as the limit, oh, excuse me, it is the same as a times the limit as x approaches c of f of x. I'll give you a really simple example. Let's say I have the limit as x approaches 9 of 2 of x. Does everybody see that the limit's 18? Because I could just plug in 9 because I don't get division by 0, right? That's the first thing I do. And I plug in the number. So it's approaching 9, right? It's a line. Okay. And so I can say that's the same as 2 times the limit as x approaches 9 of x. So 2 is a scalar. It's just a regular old coefficient. And I could just bring it out here. So the limit of this would be 9, and then I'd multiply it by 2, and I'd get 18. That's all it's saying. The sum and difference. If I have the limit as x approaches c of the function f plus the function g, that's the same as the limit of f as x approaches c plus the limit as x approaches c of g. In other words, that's going to be L plus k. So if I have the limit as x approaches 1 of x squared plus 3, I can say that's the limit as x approaches 1 of x squared plus the limit as x approaches 1 of 3. Hi, can you see that, or do I need to make that a little bigger? Yeah, okay, I'll make it bigger. Is that better? Okay. So Kaya, when I put 1 in here, I'd get 1, correct? If I put 1 in here, Kaya, what am I going to get? 3. Whatever x is doesn't matter because that's always 3. It's a horizontal line that's just at 3. Okay? So I would get 4 as an answer here. The product, I'm going to slide it over here to make sure everybody sees it, is the limit as x approaches c of f times g is equal to the limit as x approaches c of f times the limit as x approaches c of g. So you can break it up using multiplication. Yes, ma'am. Can I do what? Move it so you can see it? Yeah. Yes, I will. Thank you. And I'll show you where I use this. Let's say I have the limit as x approaches pi of x cosine of x. Well, I could say that's the limit as x approaches pi of x times the limit as x approaches pi of the cosine of x. Dom, what would be this limit? Pi, perfect. Excellent. So it's going to be pi times, what do you get on this? What's the cosine of pi? It's on the opposite side of 0, -1. Very good. So I get negative pi, right? I think you're kind of seeing the pattern, aren't you? I don't think I got to give you a ton of examples. The quotient is, I'm going to shift this way. The limit, I wonder if I can do this. Yeah, I can. I'm going to do this right here. Do this. The limit as x approaches c of f divided by g will equal the limit as x approaches c of f over the limit as x approaches c of g, which would be L over K, as long as what, Haley? What thing do I always have to be careful of?
That the bottom doesn't equal 0.
Right, K can't be 0, right? Excellent, way to be. The power, I'm going to write E right here. And I'm going to shift it over so you can see the limit as x approaches c of f of x to the, oh, I don't know, what letter should I use? N, I suppose, is going to be the same as the limit as x approaches c of f of x to the nth, which will be L to the nth. That one we use a little bit in BC. This one is going to be f, which is the limit as x approaches c of the nth root of x. I'm going to draw a little arrow here. That's going to equal the limit as x approaches c of x, and this limit to the nth root. So I get, oops, not x, f of x. Oh, I could put, I think I wanted, yeah, I'll put x in here. So that's going to be, what's the limit as x approaches c of x? Well, that's going to be c. So this is going to be the nth root of c. Does that make sense? Right, the limit, x is simply a line, right, that goes at a 45-degree angle. It's continuous. So whatever x is, that's what the limit is going to be. Okay, I see people nodding. Okay, I don't want to make that more complicated. And then g is going to be the limit as x approaches c of f of g of x, means I'm going to have the limit as, yep, thank you. See, that's what happens. I start doing math and I forget you're here. Limit as x approaches c of f times the limit as x approaches c of g of x. And I know what that is. That's going to be k. And this is some constant. Would you agree with that? And so we're going to get f of k here. That one's kind of funky. Okay, have I paused long enough? Because I felt like I was going really fast there for a while. So let's take a look at these. The sign is continuous, right? You guys know what the sign looks like? It's a nice
Could you go
wave.
back a quick second? I didn't get all that.
Okay. Is that what you want to see, or was there more you wanted to see? That's okay?
Yep, I'm good now.
All right, thank you for doing that, by the way. Okay, so this is a continuous function that's a wave. So this is simply going to be the sine of c. This is a continuous function. This is simply going to be the cosine of c. Now, all of these limits are defined in their domain. Yep, I'm going to slide it over right now. And all reals are in the domain of sine and cosine, correct? However, you can't put pi over 2 in here. So the limit of the tangent of pi over 2 would be undefined, right? Because it would be that portly little redheaded boy that is not in pi over 2 is not invited to the tangent's birthday party, correct? Right, we have asymptotes there because we have division by 0. Because cosine is 0 at pi over 2 and negative pi over 2. So when I say x approaches c, I'm saying that only those values that are in the domain. So this will also be the tangent of c. So you don't have to worry about pi over 2 or a negative pi over 2 because they're not there. You don't worry about something that's not there. That kid isn't going to cause problems if he's not in the house, right? The same thing with cotangent. The same thing with secant. And the same thing with cosecant. So it's pretty straightforward. So we're going to go through some examples. Now, this is a function, correct? I am saying that f of x equals 15, correct? Right, Darcy? So it's a horizontal line, correct? And if I move along the x-axis, left or right, doesn't matter. If I go up, I have a ceiling, right? That's never rising. It's always 15, correct, Darcy? So the limit and I put pi in here because pi is kind of scary. You know, it's 3.1415. You know what's scarier than pi? E, 2.718. But I have a constant here. So a limit of any constant is going to be a constant. So what would it be here, Darcy. Pardon? I'm going to draw a picture. Here's pi. Here's my function. So I move here. Remember, your limits are your y values. So what do you think will be? 50. And the reason I talk about that's a tough problem for students. It was a tough problem for me. I was great at making the easiest problems hard and actually figuring out the hard ones. It drove me nuts. Again, when it's a constant, it's just going to be a constant. Everybody got that? Now, the first thing I try to do is substitute. So Bryn, can I substitute 4 into this function?
Yeah.
Yeah, because you're not going to have division by 0, right?
No.
So do you know what 4 cubed is?
64.
Bingo. Good. Did you know that off the top of your head?
Yeah.
Very good. You know what you get when you double 64?
136.
I get 128.
Yeah, that's right.
Okay. You know what you get when you add 1 to that?
129.
And that's what the limit is. Okay? So the first thing you're going to do is try to do substitution. Everybody have that. Okay? First, unless it's a constant, let's go to the next page. Okay. And what I'm going to write here in the upper head is steps to find limits analytically. Okay? Step 1, substitute. First thing you do, plug that number in. Sometimes I forget to do that. And Bryce, I end up getting more work than I have to. It's like, really? I could have plugged in that, I'd be done. I'd be on to the next problem, okay? So Bryce, we're gonna look at this, and if I look at this denominator, right? This is what we call a rational expression because it's in fraction form. And that's a -1. I don't know if you could see that. I'll slide it so you guys can see it. That's a -1, okay? Can I plug it into, I don't even care about the top. Can I plug it in there? No. So the first thing that goes through my mind is, well, that's not an answer, okay? I usually say this, poop, I got work to do, okay? So the second step I'm going to do is I'm going to factor. Now I gave you a real hard one, okay? And I'm going to tell you that this is factorable. And I'm going to show you how to factor it. A long time ago, you factored that. And what you did is you removed that memory from your brain, or you buried it so deep because it wasn't a pleasant memory that you can't recall it, okay? So I'm either going to retrieve that or try to burn it into your head, okay? So it's a binomial, correct? I take the cube root of x cubed, which is x. Now notice I'm going to do something on the side, and then I'm going to, because I want you to know how to show your work and get it correct on a quiz or a test, okay? Because I'm really picky. And then you write the plus sign. And then I take the cube root of 1. That's a nice one. That's what? 1. And then I put parentheses around it. And then I'm going to have another set of parentheses, and I'm going to have a trinomial. And it's called a prime trinomial because you won't be able to factor it. These will be 2 primes. It's kind of like this. The number 6. only has 2 prime factors. Do you know what they are? 3 and 2. Those are the only 2. Okay? So when I look at this, I think of 6. Here's my 2. Here's my 3. Okay? I'm going to square the first term. And this is the part. There has to be a minus sign in here because if I would have 2 terms here and 3 terms here, I would get a total of 6 terms, correct? Something's got to die, right? Something has to be eliminated along the way. Something has to be canceled. And the only way you do that is you need a negative, correct? And there's my negative. And I'm just going to take 1 times x and get x. And you only have 1 negative. And then I'm going to square 1 and get 1. That's it factored. Okay? Now, I'm going to do a little side here to see how well you can do this, Bryce. Okay? You ready? Okay. I'm going to write x cubed plus 8 equals. The first thing you're going to give me is a binomial. Do you know what that binomial is? X plus 2. Perfect. Then the next thing you're going to have is this is going to be a trinomial. So there's going to be 3 terms. What's the first term? Perfect. Here's the hardest one. What's the next term? That's correct. Negative 2x. Okay. And the last term is always going to be plus what? 4. Okay. Perfect. Okay. I'm going to give you another one. You ready? X cubed minus 27. You're going to have a trinomial. Excuse me, you're going to have a binomial, and then you're going to have a trinomial. Let's see how good you can do on this one. You tell me what to write here.
X minus 3.
Perfect. Okay. Now, Bryce, I'm going to tell you, you only get 1 minus sign and you just used it. You don't get to have 2 because it won't work. So what's in here?
X squared plus 3x.
Yeah.
Plus 9.
Perfect. Not bad, is it? Okay. So anyway, we're back to here, correct? And over here, I'm going to write that's x plus 1, right? So what I'm doing is I'm doing my factor work on the side. Okay? Everybody got that? I'm doing my factor work on the side. And this x plus 1 is what causes the problem. It's not the top, it's the bottom, right? Because I can't have division of 0. So what I'm going to do is I'm going to get my red pen, and I'm going to go wham! Drop, drop, drop. Okay? And I'm going to write this up here. Equals the limit as x approaches negative 1 of x squared minus x plus 1. Now, Christian, the reason I like this one is I can now do straight substitution because I don't have division by 0, do I?
No, you don't.
No, because on the bottom is a 1, right?
Right.
You know, 1 is safe. So now if I put a negative 1 in here, I get 1, right?
Yeah.
Minus a negative 1 is,
Plus 1.
yeah, which is how much now?
Just 2.
Plus another 1.
3.
Do, 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 do. My favorite number. Okay. So these 2 functions have the same limit. Right, Christian?
Yep.
They're identical in every way except what? Where are they not identical? They would look the same, except this will have something that this won't.
Denominator that can equal 0.
Correct. So what gets put, if I graphed this one, if I asked you to graph it, it would look like this graph, except what would be on this graph?
An asymptote, right? The thing that makes it not go, so just like it's
Yeah,
an
so
exponential.
I can't put a -1 in here. I'm not, so at a -1 comma 3, what would be here on this graph?
An
Because
asymptote,
this is
right?
going to look like a parabola with what in it?
An asymptote, right? Is that what it's called, or am I butchering that?
I don't know. I call it a hole,
Oh,
right? There'd be a hole at a -1 comma 3. Does everybody see that? Because I simplified these factors. So when you simplify, you get a hole created, and that hole will be at -1 comma 3. And this will be a parabola with no hole. So if I asked you to name this function and I asked you to name this function, you would have to give it different names, correct? Because this is continuous, this is not continuous, though they have the same limit. Does everybody understand that? They have the same limit. So if I called this F, I could call this G, E, B, M, whatever I want for a name of a function, right? I just can't call it the same as this one because they're not the same. Does that make sense to everybody? Because I can't put a -1 in here. I can put a -1, and I'm using this to figure out this limit. And here's my work. I am ready for the next problem. Does everybody have that? All right. So I come to this, number 4. And the first thing I try to do is substitute. And I try to put a 0 in the denominator, and I can't, right? And this has got a square root sign, and it scares me. So we're going to review a little bit something. I should know your name, and I went blank. Will you say it again? Oh, yeah, Ari. So Ari, do you know what, and I'm going to slide this over. Do you know what conjugates are? Have you ever heard of them? So in my family, I have conjugates. I have my younger 2 brothers are twins. They're identical, still to this day. If I remember, I'll show you pictures of them. They are their 2 best friends. If you ask their wives, the wives always say this: we knew we'd be second, okay? One's Bruce, one's Bill. Now, they're not just identical twins, they're opposite twins. Let me tell you why. Bill's left-handed, Bruce is right-handed. Bill is nearsighted, Bruce is farsighted. Bruce parts his hair on this side, Bill parts his hair on this side. Bruce has a mole here, Bill has his mole here. Bruce looks more like my mom's side of the family, and Bill looks more like my dad's side of the family. They are conjugates. So what are conjugates? They're kind of like opposites, but the same. So 5 minus 1 is a binomial, right? Its conjugate is 5 plus 1. X minus 2, its conjugate would be x plus 2. Do you remember them? The same but opposite. Twins, 2 terms. Now, when I learned about conjugates, when I had to multiply, binomials, I was really happy to see conjugates and multiply them. Because if I look at the outer and I look at the inner, they're opposites, correct? And when you add 2x to a negative 2x, you get what? 0. So I never have to do the inside. I just have to write x squared minus 4. Bingo! I'm done. Correct? So I'm going to use conjugates here. Because if I square a square root, the square root is gone, correct? So I'm going to do my work over here on the side. And I'm going to take x plus 4, because I can't factor this. Would everybody agree with this? This is a polynomial, right? You know what I mean by a polynomial? Right? The exponents are whole numbers. And I try to factor those. Well, this is not a polynomial. This is a square root function and it's just scary. So what we're going to do is tame it down by multiplying by its conjugate. This is going to be 2 here. So I'm going to put parentheses here. Right here is x, and its conjugate is the square root of x plus 4 plus 2. Here's my first term, my minus, my second term. Here's my first term, plus, here's my second term. Does everybody understand that? And since I'm multiplying the top by that, I must also multiply the bottom by that. Abisters, are we seeing this? Watch what happens when I simplify. On the bottom, I'll get x, and I'm going to put my parentheses here, x plus 4 plus 2. On the top, this square root and this square root are gone. I'm left with x plus 4. There is no middle terms, right? If I square the square root of x plus 4, I get x plus 4. Everybody okay with that? Minus whatever 2 times 2 is, which is what? 4. Cora, I'm really happy to see that. Do you know why? Yeah, I got a lot of death going on. 4 minus 4, wham, they're gone, right? And 4 minus 4 is 0, and x plus 0 is what? It's x, isn't it? And x over x is 1, correct? So I get another bam. What will I have left in that numerator? 1. Now, x was causing the problem, correct? And it's gone. So now I'm going to write the limit as x approaches 0. And what I have is 1 over the square root of x plus 4 plus 2. And I'm going to pause there. Does everyone follow my red destruction marks? Ella Gunderson, are you okay with that? Ella?
Yeah, I'm good with it.
Okay. Okay. Now look, Ella. Do you see I can plug a 0 in here? And what is 0 plus 4?
4,
And what's the square root of 4?
2,
And what's 2 plus 2?
4.
4. The algebra is hard, but the math is easy. Bryn had it hard. She had 128 times 2. That's a lot harder problem rather than 2 plus 2. You know what? I could go to my calculator now to see if I'm correct, right? I could have put this into my calculator and check my answer, either using a graph or a table, right? I know it's not continuous at 0 because it doesn't, this equation or this function is not the same as this function, is there? But this one is a good substitute that allows me to put 0 in for x. Does that make sense? Now, how do I know when to do that? Anytime I see a square root. Anytime I plug that in. Okay? All right, I gotta find my sheet. You guys doing okay? So far, we got a few more minutes. I know I'm talking a lot, but I want to make sure I get through the stuff before I get to tomorrow. Tomorrow's a little funkier. Where did I put that? I struggle with paper. Yeah, this is it right here. Super. All right. So back here where I was making my list, 3 square roots multiply by conjugate. Now, does everybody understand? We multiply, we do all this algebra so at the very end we can substitute, correct? We always lean on substituting. We're trying to make a function that is continuous at that value. And so we either factor or we multiply by the conjugate so we can come up with something that now I can substitute because I don't have division by 0. Everybody have that? So we want to manipulate in such a way. So here's the next one. The limit as x goes to 0 of 1 over 3 plus x minus 1 over 3 all over x. And Heidi, the first thing I'm going to do is try substituting. And I can't, can I?
Mm-mm.
Ella, who's that next to you? Ella, are we having visitors?
No, my dog is coming up next to me.
Your dog's going to know calculus. That is really cool.
She's listening.
Yeah. Rosie sometimes. Maybe I'll bring Rosie on a video. Okay. So we can't substitute, can we, Heidi?
No.
No. And it doesn't have square roots, so there are no conjugates, correct?
Mm-hmm.
So it has the next hated thing besides trig, because I know the order of them. I hate trig. I hate fraction. Am I right?
Mm-hmm.
And these have, I know there are some of you people out there that I could just give hugs to if I was a hugging person that like fractions, and maybe a few of you that even like trig. I loved trig when I found out. I thought it was like the coolest thing. God, geometry and algebra, how can this not be even cooler? But that's not the case. So we're going to combine these two fractions, Heidi. Do you remember how we have to do that?
Do we have to multiply so then we get the same denominator?
Yeah, we got, exactly. You said it really well. We got to multiply the common denominator. So what we're going to do is we're going to multiply the top by 3 and the bottom by 3. Would you agree?
Mhm.
and multiply the top here by 3 plus x, and multiply the bottom down here by 3 plus x. Would you agree with that?
Mhm.
Okay, so again, I do my work on the side. So I only got to do this one limit. You see what I'm saying? I used to teach this where people had to write limit after limit after limit after limit, and people would come with fruit to class and throw it at me. It was quite embarrassing. When I went home and my wife said, "Oh, you didn't do a good job again today. I see you have a banana sticking out of your ear." All right, so over here, I'm going to have 3, right, Heidi, from here, minus, would you agree, parentheses, 3 plus x over, how about if I slide it over so you can see it? Is that a good idea? 3 plus x over 3 times 3, oh, excuse me, yeah, 3 plus x, all that over x. Heidi, does that look correct? Here are my 2 fractions. I combined them like this. And here's the x that was over. Does that look okay to you?
Mhm.
Okay, so equals, I'm going to write this down because I have a tendency to forget my x. I got another fraction up here. I do not multiply these through because that's like not good. So, but Heidi, what do I get when I distribute here?
You get 3 minus 3 plus x.
I,
Oh, wait, no.
I get 3
Minus.
minus 3 minus x. Does that look, do you see why? Because
Mhm.
this minus has got to go to both things. But what is 3 minus 3?
0,
And what's 0 minus x?
negative x.
Negative x. It's perfect. Okay? So now this means the same as a negative x over 3 times 3 plus x divided by x, or times the reciprocal 1 over x. Can I make that jump with you, Heidi?
Mhm.
I divided by x, but I'm multiplying by the reciprocal 1 over x? Or do I need to do a better job explaining that? If I
I
were
think.
if I were dividing by 3, couldn't I multiply by a third?
Mhm.
If I was dividing by 5, couldn't I multiply by a fifth? So that's all I'm doing here. This is x over 1, so I'm writing the reciprocal of 1 over x. Does that help?
That makes sense.
Okay. You know I'm happy. You know why I'm happy about this?
Why is that?
Because I got a little death going on. You see this x up here? This
Oh.
x down here?
Mhm.
I get to bring out my red pen and bam, bam. And this negative x is going to be replaced with a negative 1. Are you okay with that?
Mhm.
So now I'm going to take the limit, because I've simplified, as x goes to 0, because that was the problem. I got rid of that x, of a negative 1 over 3 times 3 plus x. And we will stop right here, and we'll continue on tomorrow. Thank you.
Mr. Kruger,
Yes, Heidi.
I was going to ask if there's a certain day we need to have if we wanted to argue for any answers on the tests, like if there's a certain day we need to do that by. I know I
The
wasn't
quicker
able
you do it, the
last time.
better. Some people have been sending me emails, and I've checked their test, and then I respond to them and make adjustments appropriately. So
Okay.
I would like it done, because I have a tendency to throw out paper because I have an issue with paper because I lose stuff.
Mhm.
So I was hoping to get rid of all tests by the end of tomorrow. So
Okay.
The quicker
So
you
would it be all right if I emailed you tonight about that?
Sure. Did you take it in class or did you submit it to me?
I submitted it digitally.
Okay, so can you submit it again with your comment? Because
Mhm.
I got rid of all the ones that people submitted because my
Okay.
box is getting so full that it makes me scared. So that's what I did.
Okay, gotcha.
Yeah, so just do that. Say, hey, I got a question about this and this and this. Can you check it over? And I make the changes. There are for sure already 2 or 3 people that have increased their grades. So, okay.
All right. Thank you.
Yep.
I actually wanted to talk to you about that.
Okay.
Can I do that right now?
Yep, we can. Let me just stop this right here. Okay, I have you right here. Did you submit it or was it
It's
on?
on paper, but I pulled it up on my phone.
Yeah, let me grab it too. Okay, because I have a hard time looking at the phone.
Yeah. It's just one problem, but
Oh, you have it right there with you?
yeah. It's number 18. That should be true.
Yeah,
Putting
I'll
it
change
there
that.
now.
Okay. In fact,
Thank
I
you.
will change it right now because if I don't do